Welcome to Krishna's online lectures. Today's topic is compressibility and bulk modulus. So let's start this video. In this particular video, I'm going to discuss about the thermodynamic properties and the compressibility and bulk modulus. So here I'll start with thermodynamic properties of the fluid. Basically, there are two types of fluid we consider. One is the liquid and another is the gases. And if we talk about density of the liquid and gases, so liquid generally possess constant density, but the density of gases is variable with respect to different properties like temperature and pressure. So here basically gas is the compressible fluid. So if we talk about thermodynamic properties, so thermodynamic properties play a very important role for gases. With change in pressure and temperature, the gases also change its density, and we can define the density of the gases with this particular equation. This equation is representing the relationship between the pressure, specific volume and temperature. Here, this is the equation PV equal to RT, or it can be PV equal to MRT. Here, M value we are considering unit. So, we can define this equation like this: P by rho equals to RT, because M by V is the density. So, this will be the equation P by rho equals to RT, where P is the absolute pressure, V is the specific volume, and the specific volume is reciprocal of density, and R is the gas constant, and T is the absolute temperature in Kelvin. So we can also define the value of R. R is called the gas constant, and the value of R we generally consider 287 joule per kg Kelvin. R we are considering the universal gas constant, and it depends upon the type of gas. It depends upon particular gas. And unit of R we can define. These are different unit of R. I explained the value of R in joule kg per Kelvin. So this is the SI unit, and MKS unit of R is kgf meter per kg degree Kelvin. So this is the unit of R, and we can define the value of R with the help of equation and this equation, or we can define the value of density with the help of this particular equation. At different temperature and pressure, the value of density of gas we can define. Here, in terms of gases, we are considering change in density at constant temperature. So that process is called isothermal process, and this is the relation P by rho equals to constant for the isothermal process. And secondly, if we are considering change in density with no heat exchange, so this particular process is called adiabatic process, where heat transfer is zero or the value of Q is zero. So this is called the adiabatic process, and this adiabatic process we can define by this equation: P by rho to the power k equals to constant, where k is the it generally define the ratio of specific heat of gas at constant pressure and constant volume, Cp and Cv. And this value we consider for air, it is 1.4 only. Now let's come to the main topic, that is compressibility and bulk modulus. So basically compressibility we can define as the reciprocal of bulk modulus of elasticity. So first we have to define the bulk modulus of elasticity, then only we can define the compressibility. So let's see what is bulk modulus. Bulk modulus basically we can define as the ratio of compressive stress and the volumetric strain. Compressive stress we can also consider increase of pressure. So bulk modulus is also called increase of pressure divided by the volumetric strain. So this is the basic definition of the volumetric strain: compressive stress divided by the volumetric strain. We can define the bulk modulus and the compressibility by one example. So this is the piston cylinder arrangement. Here we are considering this is the cylinder, and one gas is filled inside the cylinder, and we are applying some pressure with the help of piston on the gas which is filled inside the cylinder. And the original volume of the gas we are considering V. So V is the volume of the gas inside the cylinder, and the pressure P is applied by the piston on the gas on volume V. Now, if we increase the pressure which is applied by the piston, firstly we are applying original pressure is P. Now, if we are increasing the pressure with dP, so the increased pressure on the gas is P plus dP, and here piston is what it is compressing the gas inside the cylinder. So because of that, the volume of the gas will decrease. Here original volume is V, and if we are considering decrease in volume because of the compression which is applied by the piston is dV, so the change volume will be what? It will be V minus dV. So this particular term is representing decrease in volume. So we can define the volumetric strain with the help of original volume and the decrease in volume. So volumetric strain is always will be dV by V. dV is the change in volume and V is the original volume. So volumetric strain will be dV by V, and here volume is decreasing. Here in this particular condition, volume is decreasing. So the volumetric strain will be negative. So we can define the bulk modulus with the help of this volumetric strain and the compressive stress, or the increase in pressure. So this bulk modulus we generally denote by K, and this will be what? Increase in pressure divided by the volumetric strain. So increase in pressure we know it is dP, and the volumetric strain is minus dV by V, so it will be minus dV by V. So this is the formula of the bulk modulus, minus dP by dV into V. And compressibility we can define by the bulk modulus. It is the reciprocal of bulk modulus. So compressibility will be 1 by K. So if we are considering this value 1 divided by this value, so this will represent the compressibility. For isothermal process, this is the relationship K equals to P. K is the bulk modulus and P is the pressure. As per the relationship, P by rho equals to constant. That is for the isothermal process where temperature is always constant. And for adiabatic process where the heat transfer is 0, this is the relationship which is representing the relationship between the pressure and the bulk modulus. So it is K, this capital K is representing the bulk modulus, and P is representing the pressure, and small k is representing the ratio of specific heat. So this is for the isothermal process, and this is for adiabatic process. Thank you so much for watching this video. You can subscribe the channel for more lectures related to mechanical engineering, and please share this video for the benefit of different mechanical engineering students.